Every living thing on the planet, from yeast to plants to humans, has survived for billions of years by answering one simple question. When do we spend resources and when do we save and recycle? Your body still runs on that exact same decision system to this day. And there are two signals that we need to understand that quietly decide everything about your body, from muscle growth to aging. Hello, health champions. Today we're going to talk about the number one way to maximize autophagy. And autophagy literally means self-eating. And that's a bit strong of a word, but what it does do, autophagy increases the recycling and the cleanup. So the cleanup is when it starts looking around and it starts eating the debris, the leftovers, and it recycles that. So it's kind of a self-eating, but it's not like you're eating up your most vital tissue. You're making it cleaner and working better. And when we manage to get some autophagy activity, what they have noticed is we get improved metabolic health, we get improved immune function, and we also get improved longevity or health span. So a lot of people think about anti-aging or longevity to just living longer, and they're almost afraid of it because they don't want to get old. But what they do want is they want to be healthy longer, and that's what health span is. But what happens is if you manage to get this autophagy going and you increase your health span, not only do you live longer, more years, but you also have a higher quality of life for much, much longer. And the number one absolute best way to maximize autophagy is to fully understand and apply the two switches that I mentioned in the intro. There are two master switches that determine virtually everything about you and how your body spends resources. And then there are a few associated and contributing factors we're going to mention as well. And these two switches are related to feast or famine, because ever since the beginning of time, every living thing has had periods, has had cycles of more and less. There have been times we have more, there are times we have less. We often call those feast and famine. But what's really interesting about the feast and famine is not that we have just developed a system to survive despite the fact that we have these cycles, but the fact that every living thing on the planet actually gets healthier because of these cycles. It is more healthy to have cycles of more and less than it is to have abundance. So when there's a period of plenty, when there's a feast, then every living thing starts growing faster, they reproduce, and they store energy and resources. But the thing most people don't understand is that during the famine, during the time that we have less, not only do we save and become more efficient, but we also repair more and we recycle. We improve the quality of things in the body. And there are two switches that contribute to this system of balance, and they exist in every living thing. Now, there are not many things that we can say that about. That it doesn't matter if you're a broccoli plant or a pine tree or yeast or a fruit fly or a cow or a human. You have the same mechanism, the same cellular mechanism in place. And when these two switches can work against each other, they can create balance and health and longevity. But the reason that it's so important that we understand and talk about this is that this system has basically been unchanged for 2 billion years. Very, very few variations and deviations until the last 50 years. The last 2 to 3 generations, humans have deviated from that balance. It's the first time that we don't have the cycles of more and less. So it's kind of mind-boggling if you think about it, that something that has been unchanged for billions of years, now all of a sudden since 1950, we live in a whole different world. So the two switches ask two questions. The first one asks, when do we spend resources? And the second asks, when do we save and recycle? And the first one is called mTOR, and we'll talk more about that in a second. That's the on switch. That's the grow switch. And that's the one that asks, how do we look on the building material situation? Do we have enough building blocks? And if the answer is yes, then we start building. The second switch is called AMPK, and we'll come back to that also. That's the fuel gauge. And it will ask, do we have enough energy to drive the building process? And if the answer is no, then AMPK is activated to conserve and economize. So let's start with mTOR. And it used to be, they call that mammalian target of rapamycin. And we'll break this down. I'm going to go into some detail just because this is such an interesting and important story. So rapamycin is basically a form of chemical warfare. And the reason we're interested in it in this context is that it completely shuts off mTOR. It's the strongest inhibitor of this switch that we know of. And this compound was accidentally more or less discovered, and it's produced by a bacterium of the species Streptomyces. So that's where that name comes from. The second part of rapamycin comes from myces. And they discovered this on the island of Rapa Nui, which is better known as Easter Island. And at first they thought it was inside the volcano, basically in the crater, that they found this. And at first they thought it was only ever going to exist in that one place, but later they have found it on several different continents. But it is very, very rare. So in the beginning, they were a little confused. They didn't really understand what it was fully, but they did some research and started understanding it. And mycin is basically what they call antibiotics, an antifungal antibiotic. So that's where the name rapamycin. They thought this was an antibiotic. In fact, it's not. It's produced by bacteria, whereas antibiotics typically kill off bacteria. But it is sort of the same principle. It's a toxin. It's a form of chemical warfare. And then, of course, the purpose of their research was not just to understand it, but to create a drug or a medication that they could patent. And this compound now, which is the same as rapamycin, they market as sirolimus. And the first use they had for it, where it kind of served a new and unique function, and they improved the rejection rate of organ transplant. So typically, your immune system, anytime you get something foreign, like a foreign organ in your body, your immune system tries to reject it because it's foreign. But with this rapamycin, they managed to dampen the immune system to the point where they improved the acceptance of these organs. But now there's a discussion, and there's two camps on this, and they haven't gotten very far in agreeing. So they try to make it a drug also for longevity, because it shuts down mTOR, which is the growth, that when we have lots of resources, it basically creates autophagy. Now, the problem here is it definitely works to create autophagy. The problem is it also shuts down your immune system. So is that really something that we want to play with? So they're going to have to learn a whole lot more before it ever gets approved for that, and before we know if it's even close to a good idea. So when the mTOR switch is turned on, when we have plenty of resources, now muscle is built, cells grow, damaged tissues are repaired after injury. And this type of repair is very different from the repair in autophagy, because we have repair in both cases, but this is kind of the big, bulky repairs after injuries, whereas the repairs in autophagy is the subtle cleanup and tweaking. And we also are in a state where we support reproduction, and all sorts of growth in the body is prioritized. But the name mTOR is a bit of a misnomer. It doesn't make sense to call it that. And that makes it kind of confusing, because when we call it mTOR, target of rapamycin, it sounds like it exists for the purpose of rapamycin to come along and act on it. But the switch is much older than rapamycin's. The switch existed about 1.5 to 2 billion years ago that they know for sure. However, the different forms of streptomycin and rapamycin produced by the bacterial species Streptomyces is less than 450 million years old. So there's a gap of at least a billion years. And the ability of these bacteria to make rapamycin evolved as a defense against soil fungus. So if they had something to kind of kill off some of the fungus, then there were more resources available for the bacteria, so they were better off. So that was the real purpose. It wasn't to fill this switch mTOR, it was to defend themselves against soil fungus, which, of course, the soil fungus also happened to have this switch. But then the fact that rapamycin fit was sort of a coincidence, and the fact that it fits all switches in all species. And this is what makes this story even more interesting, that rapamycin just happened to fit in every single switch, in every single TOR lock everywhere. It didn't matter, again, if you were a plant or a yeast or a human, it still worked the same way because all of these locks are essentially identical in all species. And that's not unheard of in nature. When something evolves to be so perfect, there's no need to change it, then it basically stays the same. So there's a lot of mechanisms and a lot of enzymes that go back through species for hundreds and millions of years. But other than the billion-year gap between the switch developing and the rapamycin developing, there are other evidence that it's not created for the purpose of rapamycin, and that is that there are other things that act on this switch. They just don't act quite as strongly as the rapamycin. So amino acids, for example, will activate this switch, especially leucine and arginine. And why are we talking so much about this in this video? Because when mTOR is activated, anything that activates mTOR will basically shut off autophagy. And the very popular bodybuilding supplement, branched chain amino acids, contain leucine, isoleucine, and valine. So here you have a lot of this leucine that will shut off autophagy immediately. Other things that will activate mTOR and shut off autophagy are protein powders in general, high protein diet, and hormones like insulin and IGF-1, insulin like growth factor 1. Also physical stress. So if you do especially things like resistance training or weightlifting where you break down tissue, now your body, if you break it down, you stimulate the body to go back and repair the broken tissue, but also to grow stronger tissue so you're not so vulnerable to that stress. And then there are a bunch of things that inhibit mTOR, that shut mTOR down, meaning they will allow for autophagy. So here we have fasting and calorie restriction, meaning we don't have resources to build, so then mTOR will shut off. And then there are a bunch of different plant compounds, phytochemicals. So one of the most best known is curcumin, which we get from turmeric. We have resveratrol from red grape skin and red wine. We have EGCG, an antioxidant from green tea. And we have quercetin that we find in fruits and vegetables. And then we have a couple of compounds in olive oil called oleocanthal and oleoropine. And all of these have been found to have some impact on inhibiting mTOR, but none of them have managed to create such a complete, potent turnoff as rapamycin. And now let's talk about the other side of the equation called AMPK, the other switch that helps us save. And AMPK stands for adenosine monophosphate activated protein kinase. So it's an enzyme, and whenever we get really low on energy, then this gets activated. So if you think that AMP sounds kind of similar to ADP and ATP, which is our body's energy currency, you're absolutely right. So all of those have in common something called adenosine, which is basically just a form of a sugar molecule, which we use for structure here, not for raising blood sugar or anything. And then we have a connection, and we link up one phosphate molecule, and then we link up another phosphate molecule, and then a third one. And the reason I draw these squigglies is you want to think of these as springs, that a spring can store potential energy, and then when it's released, it gives off that energy. So that's basically how this works. When we have three of them connected, we have three springs loaded, if you will. And they're not literally springs, just think of them that way. They're like a chemical spring. And ATP is our energy currency. When we have three springs compressed, it's a very high energy state. When we have plenty of fuel, now we can build and we can replenish our ATP reserves and keep the fuel gauge topped off. But as we have less and less resources, now we don't replenish this. We use up the ATP, and this third phosphate breaks off, but we don't have the resources to make new ones. So now we're left with ADP, or adenosine diphosphate. So it's a lower energy state than ATP, but we still have two of these springs. But if things get really grim, now we break off the second phosphate also, and we're left with just A and one phosphate. So now we have AMP, and this activates an enzyme that tells the body, hey, you gotta go save. So this is basically an energy sensor. And you can also think of it as a fuel gauge in your car, that once you go all the way down and you start running on fumes and the light comes on, that's what the AMPK is. And of course, as smart as the body is, this is the message to conserve and economize. So what happens now is we start burning more fat for fuel. It's a really clean form of energy. And when we have nothing else coming in, our only choice is basically to burn protein or fat, but the fat is stored for the purpose of burning when we are low on fuel. So we're going to burn almost 100% fat and virtually zero protein. So when AMPK is on, we also start reducing energy waste, become more efficient, and we start increasing repair and recycling. And again, this is not the type of repair that uses up a lot of resources because we don't have them, but it recycles. It goes out into the body and it looks for debris. It looks for things that are sort of worn out. It looks at mitochondria that are a little bit rusty, and it breaks all of that down and it recycles it, and it uses some of those resources to kind of smooth out the patches and make things cleaner and more efficient. And all of that is, of course, part of what we're talking about today, of autophagy. So AMPK is a driver of autophagy. So let's give you a little more detail on autophagy just to really fill out your understanding. It is survival without building blocks. We have a turnover of cells, cells wear out, but when we don't add any new building blocks, then we have to get just really good at recycling. So we start breaking down and recycling damaged protein, which could be old cells or misfolded protein. It could be cell debris, things that are already broken and just kind of hiding in the corners or floating around. And we also recycle pathogens. That's part of what upregulates your immune system, because we're desperately looking for protein, for building blocks, and bacteria and viruses have protein. So if we can break some of that down, if we can kill them off and break it down, now we can use that protein. And we even recycle old mitochondria. When they get a little inefficient, a little oxidized, a little rusty, Now, if we break them down, now we have building blocks to make new ones that can run a bit cleaner. And in doing that, we reduce the overall cellular noise, you can think of it, and we reduce inflammation. So in this context, growth and recycling are complete opposites, which is also why mTOR and autophagy are complete opposites. Anytime we trigger even a little bit of mTOR, we shut off autophagy. So I want to quickly mention insulin in this context because it's very powerful. Insulin is released in the body in response to increased blood glucose, which is basically any time that we eat food. And therefore, it's a signal to the body that resources are on the way. And insulin also promotes fat storage and growth. That's one of the most powerful things it does. And of course, at the same time, if it promotes fat storage, it will suppress fat burning and the associated AMPK. So insulin basically is opposed to AMPK. It goes hand in hand with mTOR and it very effectively shuts off autophagy. And there's several things that shut off autophagy, but they do it to different degrees. And this is where it gets a little confusing, why it's, for some people, it's a little counterintuitive why they would act so strongly. So protein is the strongest inhibitor signal. And that makes sense now that you understand the discussion that we've done here about mTOR and about building blocks. The next strongest signal is insulin, which we get from eating carbohydrates, of course. That's not quite, but it's pretty much as strong. And then calories is another one, and fat is another one. But you notice that calories and fat are much smaller X's. We can have some calories and some fat and still allow autophagy to keep going. So all these turn-off signals are quantity dependent. And we want to think about them relative to normal or relative to abundance. So if we think about this as a scale, then the top of it would be a feast where we completely turn off autophagy. And then in the middle, we have sufficient, where there may be a little bit of autophagy going on, especially if we skip a few meals, like we do a 16-hour fast or something like that. And then we have famine, where we do more extended fasting or more severe calorie restriction. So if we look at each of these in turn, and we start with protein, now an average, a sufficient number, and I'm just kind of giving you some round numbers to illustrate this, would be about 100 would be sufficient, and 200 would be probably excessive for most people. But because autophagy is so sensitive to protein, we have to get all the way down to about 18 grams to allow autophagy to continue. So in round numbers, we could say that you have to get down to probably below 20% of a normal intake to allow for autophagy. And then we look at calories, where an average level or sufficient would be maybe 2,000, and I put 3,500 as excessive because that's the average of what we eat in the United States and most Western countries by now. But autophagy can proceed all the way up to 800. So here we're basically at 40% of sufficient, and we still allow autophagy because, again, if we just keep protein low, that is the strongest turn-off signal. And the same thing with fat. A good, normal, sufficient level on a low-carb diet would be about 150 grams if we stay under 2,000 calories. And again, these are just round numbers to give the idea. 250 would probably be excessive because that's a lot of energy unless you're very physically active. But we can still allow ourselves a good amount of fat because it's the weakest inhibitor of any of the nutrients. And then let's look at insulin and carbohydrates. So if you keep calories low enough, you could still have some carbohydrates and still have some autophagy. But I just would ask, why would you do that? Because carbohydrates just makes everything harder. It creates hunger. It's not very satisfying. And if you eat fat instead, now you're not stimulating your appetite. You're not stimulating insulin. So even though there are some fasting mimicking diets that allow for a good amount of carbs, I just think that's silly. And I think it has to do with our overall fat phobia, that we just don't think that could work. But it makes every sense in the world when we know that the carbs are what stimulates insulin, and that shuts down autophagy. So on a normal full food diet, you could probably eat up to 100 grams of carbs per day, unless you're trying to reverse a metabolic problem, and then you would want to be less than that. 400 might seem like crazy excessive, but that's what a lot of people eat every single day, even as recommended by the guidelines. But I would say if you want the most out of the autophagy, then I would keep that probably below 10 grams. So the ultimate trigger of autophagy, the strongest, fastest, most potent way to do it is to just do complete fasting. Don't eat at all for 18 plus hours. And then if you're on a roll or you've prepared and planned for it, you get a lot of autophagy if you keep that fast going for 3 to 4 days. And with a complete fast, obviously, you're strongly reducing protein, which is the strongest trigger for mTOR. So you're shutting off mTOR, you're shutting down insulin, and you get the most autophagy going. And you're restricting fuel. So your ATP is going to turn to ADP and then to AMP and activate AMPK. So now you're working both switches in your favor. So if you're not afraid of fasting, that is by far the best way to activate autophagy. Now, the next best trigger are for those who are uncomfortable with complete fasting. And this is called fasting mimicking. And the way you do that is you keep your protein very low. Protein's the strongest trigger of mTOR, the strongest shutoff of autophagy. Keep it below 18 and you're still turning off mTOR. The body senses with that little protein, there are no building blocks. We cannot proceed and build stuff. When you keep calories below 800, now that is a strong signal to increase AMPK and to reduce insulin. And if you restrict those calories and you do low carbohydrates in addition to that, now you're amplifying those signals even more. You're even stronger trigger for AMPK, even stronger reduction of insulin. And the third of the macronutrients obviously is fat. So the smart thing to do is to eat less than 18 grams of protein, very, very little carbs, and then to eat fat up to about 800 calories. So 800 is a rough number. A larger person should probably be okay up to maybe 1,000 or even 1,200, whereas a smaller person might want to go with 700 or even 600. But if most of that is fat, now you're barely triggering insulin. It's not even going to be noticed if you did a test. But not all proteins affect mTOR and autophagy the same. The ones that are high in leucine will stimulate mTOR and shut off autophagy most potently. So whey protein is high in leucine. Branched chain amino acids are very high. And also all animal meats. So red meat, poultry, fish, eggs, and dairy, they're all very high in leucine. And it makes sense because these are excellent building blocks. They're very, very good proteins when you're trying to replenish the body, but we're trying to mimic the cycles of having plenty and not having so much. And we can accentuate that. We can make it more potent by avoiding these when we're trying to create autophagy. So to further maximize autophagy, you want to eat foods that are low in leucine. And those would include things like olive oil, and especially extra virgin olive oil, because that still has more of those phyto compounds that shut off mTOR. Avocado is great. Non-starchy vegetables are great. Leafy greens, herbs and spices, and plain broth. So even though bone broth is good for a lot of stuff, it's not great for fasting mimicking. It's very high in protein. Bone broth has like 4 or 5 times more protein than plain broth. But one of the best things that you could eat would be olive oil, like I said, extra virgin olive oil. And some people are even promoting olive oil fasting and saying that that's even better than total fasting because it has these phyto compounds that trigger autophagy even further. But here's the thing. They still have calories. It's still your nutrient sensors still react and say that's a resource. It's not a resource like protein, but it's still a resource. So you can never match total fasting by eating olive oil, even if it has some compounds that are beneficial. But if you're not doing total fasting, if you're doing fasting mimicking and you're getting up to about 800 calories, I would suggest making most of those calories olive oil and avocado. Maybe get some leafy greens just for bulk, but the bulk of your calories want to come from olive oil and avocado, but total fasting would still be a step up. So a lot of people are still skeptical to fasting mimicking, and they're wondering, can it really work if you're still eating something? And it's not better than fasting. That's not what I'm saying. However, if it can create better compliance, if it can increase the percentage of people who complete it, or if it can increase your probability of completing a fast, then it's a good thing. Also, if you have the fear factor, if you are just afraid, if you can't really grasp the idea of not eating for 3-4 days, maybe you could try the fasting mimicking, and if you can get it done, then that's better than not doing anything at all. But it still works remarkably well because it silences both mTOR and insulin. It shuts them way, way down. It drops the amino acids, and especially the leucine, if you stick with the sources that I talked about, and it lowers these dramatically because we go way down on protein. And even though you're still eating, it lowers calories enough to activate AMPK and to shut off mTOR and to lower insulin enough to get the job done. And you get even better insulin effects if you combine this with low carb, high fat. So let's add just a few more tweaks to get the #1 absolute best way to maximize autophagy. So you do all the things we talked about. If you can pull off a complete fast, then you do that. If you want to try for the below 800 calories, you do that. Do all that. And then you add exercise, because that's going to drive all of the processes that we talked about. It's going to amplify them. And the bulk of what you do is walking, because you don't want to overstress your body when you pull back on resources, because that would be additional stress. You want to do minimal HIIT, high intensity interval training. And you do minimal, and I do mean that. You don't want to break down any tissue. You just want to activate it enough to get some growth hormones and to get deeper into autophagy. But you don't want to do it so intense that you get sore or you break any tissue, because you don't have the resources to repair it. Same thing with weight training. You do minimal resistance training. You can do some, but it should be minimal. So basically, this is how track athletes train before an important competition. You spend all winter, you spend the training season breaking the body down, eating lots and lots of food to rebuild the body. But the closer you come to competition, you just want to tease it. And you do things at high intensity, like high intensity interval training, or you do a set of weights. You do some squats, or you do a bench press, or you do power snatch or something, but you do one lift just to tease the muscle, just to give it a little muscle tone, stimulate a little growth hormone, but not enough to break anything down. And then the last piece of the secret sauce is to increase deep sleep. And not just total sleep, but deep sleep. So how do you do that? What happens when you do that? Well, your body cleans up by your lymph system. So the autophagy happens inside the cells. They dump the waste into the lymph system that takes it back into blood circulation, back to the liver, and we can start all these things over again. The brain doesn't have a lymph system because it's too protected. It's a separate environment. So it has what they call a glymph system, which stands for glial cells. The G is glial. And those are the supportive brain cells, the ones that help the brain stay healthy, but they don't do the actual signaling. So what happens during deep sleep is that brain cells actually shrink. You can think of them as normally being slightly swollen, but at night they shrink down and there's more space between them, and this will allow the CSF to flow. So the CSF is kind of equivalent to the lymph in the body. It moves much slower, it's much less, but that's the only circulation that we have outside of the blood vessels. That's basically the cleanup system for the brain. So it's really an incredible system that the autophagy cleans inside the brain cells. All the things that the body does and the rest of the body, the autophagy is one of the few things that can actually clean up inside the brain. And then the CSF, through the CSF, the brain can take out the trash. But it's because during this deep sleep, the brain cells actually shrink to increase the spaces between cells. And here are a few hacks to get more deep sleep. And what you're trying to get into is the slowest brain waves that we have. They're called delta brain waves, and they're anywhere from 1 to 4 hertz. First of all, try to stick with regular sleep habits. You go to bed around the same time, you get up around the same time. And I know it's tempting during the weekend that you're sleep deprived during the week, you want to catch up on the weekend, but try to be more disciplined during the week if possible so you can keep those regular sleep habits. Make sure to get some bright outdoor light in the morning. In the first 30 to 60 minutes after getting up, don't sit in front of your computer. Get at least just a little bit of natural light because that is going to reset your whole circadian rhythm and get it into the proper timing. And then you want to stabilize your blood glucose, especially during the evening time, closer to bedtime. It's super important, and we're understanding more and more how important stable blood sugar is because blood sugar swings, upsets every form of balance in your body. So you want to avoid sugar and alcohol in general, and also don't have a big meal after 6 p.m. Allow your body some time to process that food so that you don't go to bed and having the body process all that food and having to work hard when it's supposed to recover. And then you want to do everything you can to promote parasympathetic activity. So in your fight-flight system, you have the sympathetic and the parasympathetic. And by the way, if you drink a lot of alcohol before bed, what's going to happen is you have a fight-flight backlash. You have a sympathetic activation about 4 or 5 hours later. So if you drink alcohol, it helps you go to sleep, but it interferes with your sleep rhythm and it wakes you up in the middle of the night. So avoid sympathetic stimulation and promote parasympathetic activity. So what you want to do is one trigger of sympathetics that revs up the brain and the frequency is blue light. So you want to reduce screen time, especially blue light. If your phone or your computer has a yellow light setting, like a nighttime setting, put that on, but also stay away from the computer if you can for the last few hours of the day. And then you can further drive the parasympathetic activity with breathing exercises, and I've done lots of videos to demonstrate and explain that. And also meditation will slow down your brain waves. You won't get into delta, but you can at least get into alpha or theta with the meditation. So you're mostly halfway there. Also, a warm shower can be very relaxing. It can warm you up, increase some parasympathetic activity, and kind of get you out of that stress mode. And one last thing is minerals, especially magnesium, helps to calm you down, but also a well-balanced electrolyte can be helpful. If you enjoyed this video, you're going to love that one. And if you truly want to master health by understanding how the body really works, make sure you subscribe, hit that bell, and turn on all the notifications so you never miss a life-saving video.